In this video, we're going to talk about how we can view PV and PV-like quantities on various weather maps. We're going to begin with talking about PV on isobaric surfaces, and the example we have here today is a 250 millibar surface that plots actual PVU values. Instead of looking at our geopotential heights as we would normally do for this jet level map, we can use PVU instead. One thing to note here, our PV is what is contoured in black. Our color shading is wind speed in knots. And the gray dashed lines are divergence, which are scaled by 10 to the 5th. What we're looking at here and what we might want to recall is that higher PVU values occur in certain parts of the atmosphere. If you recall, higher PV values are in the stratosphere where we have higher static stability, such that we can essentially see in this area here, we are in the stratosphere and viewing stratospheric air. Here, we are definitely in the troposphere. And so what we're visualizing here is a big trough. And the trough, having cold air behind it, shallower troposphere, so we're seeing at the 250 level here, our stratosphere. One thing to note, though, is that where are our jets occurring? And so notice we have a jet stream here, we have a jet stream here, and all along here. Our jet streams are occurring where we see these large gradients in potential vorticity. Note that we start drawing potential vorticity at 2 PVU. That's because basically what we're viewing here with these large gradients is a large slope in the top of the atmosphere, such as where we're seeing this transition from troposphere to stratosphere at our jet region. So it should be no coincidence that we see our jet streams along these gradients in potential vorticity. What this allows us to do is to view in a different way the evolution of our jet and trough system that we'll talk more about when we discuss in a future video the evolution of mid-latitude cyclones from our PV perspective. Now, this is not the only way we can view our PV. We can also look at something called the dynamic tropopause. And when we're looking at something called the dynamic tropopause, or the DT, what we're really viewing is some sort of PVU surface. And in this case, the dynamic tropopause surface that we're looking at in this map is the 2 PVU surface, so just slightly higher than what we would classically term the tropopause. Here, we are looking at the potential temperature on the dynamic tropopause. Basically, we're looking at a measure at this tropopause level that can relate to the depth of the troposphere. And so it turns out that in our warmer air, in our tropospheric air, we'll have higher values of potential temperature, seen by the warm colors, and colder values where we have a lower troposphere. Additionally, on this map, we have plotted the winds on this surface. So these are the winds along the dynamic tropopause. But we also have these black contours here, which is a measure of the average low-level relative vorticity. So what this map is allowing us to do is see a comparison between where our upper level features, as signified by the potential temperature in the dynamic tropopause, and our low level rotation, signified by this average relative vorticity in the lowest layers. Our colder air here is basically signifying where our trough is. And so just as in our previous map, by looking at the 250 hectopascal level with PV, or our dynamic tropopause map looking at our potential temperature, we see this trough feature that is over the west, associated with that cyclone that came through for the Chicago blizzard. And we can then visualize here a separation, a westward tilt with height, between where our low-level rotation is and where the axis of our trough is aloft, leading us to believe that there might be further development. Again, here our strongest winds are associated with where we see strong gradients in potential temperature. And so we can pick out these jet streams based on this map as well. This is just a little bit of an introduction into interpreting weather maps that view PV in various ways. We'll investigate future maps when we talk about the life cycle of mid-latitude cyclones from this PV perspective.